Our project is on image classification on chest X-ray images, presented by myself, Sai Srijan Dandiala, and Vamshi Krishna Peddi. Is to classify pneumonia X-ray images with normal X-ray images. What is pneumonia? Pneumonia is an inflammatory condition of the lung affecting primarily the small air sacs known as alveoli. Diagnosis is often based on symptoms and physical examination, chest X-ray, blood test, culture of the sputum. Chest X-ray dataset is taken from Kaggle, which contain various X-ray images differentiated by two categories named as pneumonia and normal. We have created a deep learning model in Spark, which will tell us whether the person is having pneumonia disease or not having the pneumonia disease. The main the main data source of this dataset is from Mendeley data, which was uploaded. The same was uploaded in Kaggle, which we took from. In total, there are 5,863 X-ray images, which was categorized into two categories, which is pneumonia and normal. If we see the graph, it is a highly imbalanced dataset, and we'll talk about this balance in the dataset in the further slides. If you see the below images, the leftmost image is normal and the other two images are pneumonia based. So if you see in the normal image, which is clear and it is having no opacification, but in the other two images which are not clear and contain some opacification, which concludes that the chest X-rays or the person is having some pneumonial symptoms. So we'll try to classify these chest X-rays into two categories, which are normal or pneumonia, using our deep neural network model, which is convolution neural network model. And we have labeled normal class as 0 and pneumonia class as 1. We have used the following packages: PySpark MLlib. MLlib is Spark's machine learning library. Eliphas. Eliphas implements a class of data parallel algorithms on top of Keras using PySpark's RDDs and data frames. We have used TensorFlows and Keras. Project flow. Our project flow is as follows. First, we'll take the images and we'll read those images in PySpark read image method, and we'll convert those images into vectors using Python image library, which is PIL, and we'll give the vectors to our CNN model, which is on Eliphas, and then the model will predict whether it is pneumonia positive or negative or normal. Our very first step is data pre-processing. Our train set contains 5189 and test set contains 624 and validation set contains 16. The highly imbalanced data set, which was previously mentioned, was tackled by a stratified sampling technique and in the Spark, which is sample by method. And our images are read by spark.read method. We have resized the images and we have flattened the images to 1D vector, and then we have applied scaling by the Spark standard scaler, and we have shuffled the dataset to prevent issues in the learning stage of the.
So after getting the balanced dataset, we have applied a CNN model on that balanced dataset. So in the balanced dataset, it contains around 22,500 features. So first we have to reshape all the features into 150 cross 150 because all those pixels are flattened as part of pre-processing. So after that, we have applied CNN model with five convolution layers and 5 max pooling layers. And we have experimented with batch normalization layers and strides as parameters in convolution and max pooling layers. So, but to get the optimized model, we have given strides equal to 1 in convolution layer and strides equal to 2 in max pooling layer. Gradually, we have increased the number of filters in all the 5 convolution layers from 32 to 256. To get the faster convergence, we have used Adam as the optimizer. This is about the Keras model. So after developing the Keras model, we have converted that model into a JSON format and send that as an argument to Eliphas library. Eliphas is one of the distributed deep learning library which was developed on the top of Apache PySpark. So here we have experimented with different hyperparameters. Out of those, learning rate as 0.01 and hypothesis as 25 with batch size as 32, which given us a train accuracy of 95 and a test accuracy of 92. So while doing experiments, we have implemented different layers of batch normalization and different optimizers we have tried, out of which we got good accuracy on using 5 convolution layers and 5 max pooling layers along with batch normalization, and using optimizer as Adam we got accuracy around 92% on test dataset. So finally we have developed a deep learning model on PySpark distributed environment. And coming to future works, we can try even ensembling methods and also classifying data points of pneumonia, whether it is viral or bacterial pneumonia. Thank you.